All right, guys, welcome back. It's a big day today. Listen, it is a really big day today. So the last couple of weeks we've been working with our Cisco partners or our Cisco account team and our partners, and we've gotten some really good pricing, and we finally got a PO to issue for some shiny new Cisco Catalyst 8K routers. So Cisco team's super happy. They got commission. Our management's happy. They're hey guys, when are you going to put these things in? We got to get this ball rolling. And now we've got nothing but work in front of us. So here I am. I'm at the data center. I've got these puppies racked. They're wired in, and I just powered them up, and they've been upgraded. Okay, fine. I'll stop. I'm sitting in my basement. This is a fake background, and I'm not at the data center. I know. It's so disappointing. Anyway, we will be configuring some AK boxes today. We're going to port channel them up to the edge switches, and with any luck we'll be able to get on with the service provider. I gotta stop. We're not getting on with the service provider. We're just going to pretend to get connectivity out to the internet. So without further ado, let's get into it. Okay, so let me get connected to DC1, INET 01 and 2. We might as well get on the edge switches as well, and we'll focus in on ISP-A first, okay? So first things first, let's just get the routers VPC'd up to each edge switch. We don't need this server, we can get rid of him. Okay, so brand new, right? No configuration. So let's go ahead and go through the motions real quick. And then 0, so that way we don't need to enforce any of this stuff. Let's get logged into the edges. Admin Cisco. Okay. And then we're just going, oh, he doesn't have a config either. So all brand new except the edge switches. All the routers are new. Okay. So let's check the edge switches for port channels. What do we got going on here? Okay, so we've got port channel 1 and 3. We know that 1 is going to the other edge switch. We know that 3 is going down to the firewall. So that leaves us 2 and 4 to work with. So we'll configure 2 for router 1 and 4 for router 2. So let's just go ahead and get this done. So we know that port 1.1 is going to router 1, so we'll do interface ETH 1.1. Sorry about that. So we'll no shut switch port mode trunk, and we'll say channel group 2 mode active. We'll hop over to channel group 2. We'll say switch port mode trunk, and we'll say VPC 2. Okay. Obviously, that's not going to come up until we configure all sides and the other side and the other switch. So let's go ahead and do interface ETH 1.1, switch port mode trunk, channel group 2 mode. Let me just do a quick verification here. Okay, we're good. Channel group 2 mode active. We'll no shut just in case. Interface port channel 2, switch port mode trunk. I gotta give the prompt the chance to catch up. Okay. VPC 2. Okay. So quick verification, show port channel summary. All right, so we've got port channel 2. He's waiting to be aggregated. Show port channel summary. Okay, suspend it, whatever. That's all fine. We'll get all this fixed once we get the router up. So let's just do show VPC. We can see that 2 is created and ready to go. It's obviously just not up. Okay, so let's hop over to the router. So So enable, we'll give them a quick host name, DC1 INET 01. All right, and then remember, if we go into the interface first and try to do channel group, it'll yell at us and say that the port channel is not configured. So we're going to just create the port channel first. So interface port channel 1. This is the only port channel that this router is going to have. Okay, so now we can go into interface gig 1. We'll, just to show you guys, brand new router, interface gig, wait, what? 3, 4, 5, 6. What's that about? These things are flaking out again. Look at this. Show IP interface brief. That is wild. What's this one show? Okay, that's goofy. Okay, I'm going to pause the video and reboot these things and see what the heck's going on. Something's not right. I probably have to power cycle these things or something. So we'll reconvene here in a minute. All right, guys, that was weird. I had to power them off and on. It was really strange. And then obviously I didn't save the config, so we lost the config, but that's fine. We didn't really do much. Super weird. So if I do show IP interface brief, so now we've got 1 through 4, so that's, hopefully we don't see any weirdness with this config. If we do, I'm just going to probably just restart this whole thing, but at any rate, interface port channel 1, interface gig 1, no shut, and we'll assign channel group 1 to it. Same thing with gig 2. Channel group 1 mode active. Okay, so we have 2 interfaces that are turned up. The port channel has been created. With any luck, the port channel will come up. I gave this the wrong host name, didn't I? Yeah. INET 02. Okay. Okay, this is INET 01. Interface port channel 1, no shut. Interface gig 1, no shut. Channel group 1 mode active. Interface gig 2, no shut. Hit the up arrow a couple times. There we go. So let's give this a second for these ports to come up. Okay, looking good. Let's go back to the edge switches, show VPC. Okay, awesome. So now we've got VPC2 is up. Okay, cool. So let's do VPC4, right? We said that was going to go to router 2. So these are interface 1, 2. And 1, 2. So 1, 2 on each edge. So show run interface ETH 1, 2. Okay, we've got nothing, right? So ETH 1, 2, no shut, switch port mode, trunk. Channel group 4 mode active. Hop over to the port channel 4. Switch port mode trunk, and then VPC4. All right, looks good. Let's go over here. ETH 1, 2. No shut. Switch port mode trunk. Channel group 4 mode active. Interface port channel 4. Switch port mode trunk. And then VPC4. Okay, so that should give us the port channels. What's router 2 complaining about? Hopefully it's just negotiating. We'll see here in a second. Let me just flap this poor channel and see if that does anything. So far so good. Okay, that's better. So we had to flap port channel 4 for whatever reason. You know, maybe it was a timing thing, not really sure. Okay, good. So that's our foundation. We've got the VPCs are done. So hopefully we're done with VPCs for a while. I feel like that's all we've done in like the last 4 videos. So they're there, they're built. So now it's time to start slapping on some IP addresses. So we can just, the IPs that come from the internet service providers are just kind of irrelevant, right? So we'll just make something up. So we know that our publics are 101. So this is what the Cisco fake data center owns. We're going to advertise to the internet. What we'll do for maybe the connectivity to the ISP is we'll just do like 201. We'll just make it easier on ourselves. Maybe we could just do 201, 1 for router 1, and then we'll make it a /30, right? And then we'll do 201.1.2 for router 2, and then we'll make them the /30 addresses. So let's just do that. It's just easy to remember kind of thing. And we're only going to use these addresses for basically peering with the service provider with via BGP, right? So it shouldn't be a big deal. So on router 1, and then the other thing we have to do is choose a VLAN number. So in this example, so let's start on the service provider side. It'll make more sense. So let me go over here. I think it'll drill the point home a bit better. Hostname, INET, ISP, A. Okay. Not interface hostname, just hostname. Okay. So his gig 1 interface is what is going to connect to the edge switch. Okay. So he's just going to have a straight up IP address on gig 1. All right. So we'll no shut. We'll say the description. We'll just say Cisco DC router 1 for router 1 or whatever. It doesn't matter. We'll do Cisco INET 01. How about that? His IP address is going to be 201.1.1, and he'll always be .1. And we'll say /30. Okay, so that's all we really need to do on him. Just give him an IP address, okay? Now, remember, it plugs into the edge switch, because all we want to do here is just essentially trunk or VLAN, however you want to see it, trunk it over to router 1, all right? That's all we're really trying to do. So this VLAN number that we assign, it's arbitrary. It can be whatever we want. As long as we set the encapsulation .1Q to be whatever that VLAN number is on our router, that's all that matters. But it can be any number we want. So we can just say, like on the switch, we can just say VLAN 801. So I like to choose a higher number VLAN that's completely in a range that I know I'm not going to use for any of my devices. So 801 is kind of a perfect fit in my opinion. So we'll just say VLAN 801 and we'll call it ISP-A. And then we're gonna, what I would suggest is doing, VLAN 802, and that will be for ISP-B. So we'll get there in a few minutes. But let's just use 801 and 802. And we'll go ahead, we'll just define those on both edge switches while we're at it. All right. and then we'll do 802, which will be B, okay? So the only thing we have to do, well, there's a couple things we have to do, but facing the ISP on edge 01 is port 4. So if we go into port 4, 1, 4, and that is ISP-A handoff, okay? That's where the handoff is plugged into our switch. So we'll say switch port mode access, and we'll say switch port access VLAN 801, okay? That's all we're going to do for that port. Just make it a straight up VLAN port that's facing the ISP. However, the difference is on the port facing our router, right? So E1, which is, sorry, I'm thinking random thoughts. So on edge 01, we had put him in the port channel, right? So we had said, what was it, port channel 2, I believe? 2 was router 1 and 4 was router 2, right? So on the so he's set as a trunk. So there's nothing he's already done. That's what's giving me I'm overthinking this. We already did the VPC and he's a trunk. So in theory, 801, so if we do show interface trunk, we should see that on port channel 2, for VLANs allowed on the trunk for port channel 2, we should see everything, okay? Now you could prune that, right? You could prune that to be the VLANs that we're strictly going to be sending to router 1, which there's going to be another VLAN, which we'll see in a minute here. But for now, let's just leave it open. We'll just let all the VLANs go to router 1. Okay, so in theory, we've got an IP address on ISP-A. We made the 1.4 an access port. E1 is part of port channel 2, which is already a trunk. So let's go right to INET 01, okay? And we've got the port channel sitting there waiting for us. So all we're going to do now is do what we already know, which is router on a stick, but we're putting it on the port channel. Interface port channel 1.801, okay? Encapsulation.1Q 801, and we're going to give it the other end of that /30. So we said 201.1.1, and we're going to be .2 /30, okay? Now, if we did this right, we should be able to ping 201.1.1.1. Okay, awesome. So we can ping him, right? And now, just for giggles, right, if we went over to ISP-A and we did show IP ARP, we should see that the 201.1.2, this should be our MAC address on our interface port channel 1.801, right? So if we showed interface, show interface port channel 1.801, this 52C0 should be what we saw over on the router. So that's a good verification when you get on the phone with the service provider. If you're having issues establishing connectivity, sometimes they'll ask you to verify MAC address, stuff like that. And what they're doing is they're trying to make sure that their layer 2 is essentially configured correctly. Sometimes they do tags. So in this case, they're not doing tagging, we are. But you never really know what magic the service provider's doing because they're a service provider. They have to do certain things for monitoring and stuff like that. So, okay, so that's good, right? So we've got connectivity from our router to the ISP. Now we haven't done any protocols, nothing like that. We're slowly getting there, right? But let's just do the same thing on router 2. Let's get that circuit to ISP B up and running. Okay, so let's connect to B. And I think he's going to be a clean slate. Yep. Whoops, I should not have done that. I should have pressed 0 instead of 2. All right, well, while he's thinking, let's go. Oh, there you go. Fine. So now it's going to force me to put the password in, which is kind of annoying. It is what it is, right? Okay, so this is ISPB, right? Hostname INET ISP B. Okay. Interface gig 1. Let's just grab the show interface descriptions. Cisco INET 02 in this case. Okay, and then he just gets an IP address. So we said 201.1.2 for router 2. We said the service provider is always going to get the .1, and we'll make it a /30. We'll no shut him. Show IP interface brief. Let's just save it. Okay, good. I think I saved him, but let me do it anyway. Same story, right? The VPC is already built. It should be good. We built the VLAN. ETH 1.4 on Edge 02. Let's just verify, because I can't remember if we put that in the VLAN. I don't think we did we? We did not. So, interface ETH 1.4. I just want to see what I called it. Called it the handoff, right? So, ISP B handoff. And then he's going to be a switch port mode access, and switch port access VLAN 802 in this case, okay? So if we want to verify that, we can do show interface trunk. What we should see is on port channel 4, okay, under allowed VLANs, we should see all of them, which we do, so that's a good sign. So now if we come back to Internet 02, show IP interface brief. Again, port channel sitting there waiting for us. We're just going to do interface port channel 802, encapsulation.1q 802, and we're going to give ourselves 201.1.2.2/30, and shouldn't have to no shut them, but I do out of habit. Ping 201.1.2.1. Okay, good. So we have two working internet connections that are essentially trunked, router on a stick, however you want to think about it, between us and the service provider. So that's a great sign. Let's just go ahead and, where are we at here? We're at 16.5 minutes. So let's go ahead and do BGP. We'll just do basic BGP. We're not going to do any bells and whistles. Let's just get the BGP sessions established, or the neighbors established between us and the service provider. So if we look at the key, we're going to pretend that we're ASN 101, okay? So we'll start on router 1, and we'll say router BGP 101, okay? We'll go ahead and we'll turn the routing process on, and let's just do we'll do neighbor 101 in this case, because it's ISP-A. 101.1.1.1. That's the ISP-A, okay? We're .2, he's .1. His remote AS, we didn't determine that yet, did we? Why don't we just do AS1 for him, AS2 for B, and we'll make the internet loopbacks 3. We'll make it super simple. So he's going to be remote AS1, all right? So, and we'll go ahead and activate him so it does the IPv4 address family. Activate. Okay. So when we do show run section BGP, we should see that we have nothing more than a neighbor statement, and we've just activated him to be an address family IPv4. So very simple, nothing going on. We'll start going through some of the routing pieces in the next video, but let's just get to a point where we feel like we're comfortable. So now we're going to go to we're going to play the role of the service provider. We're going to go to INET ISP-A, and we're going to do router BGP 1, okay? We're going to say neighbor 101.1.1.2, and he's in remote AS 101, okay? That's us. And then we'll go ahead and we'll activate him as well. Okay, So if we show run section BGP, nothing more than basic BGP with the neighbor statement and the activate, okay? Did I? Oh, it's 201. I'm such an idiot. All this time. 201, not 101. Oh, yeah. Show run section BGP. Let's just fix it real quick. My mistake, guys. Sorry. Let's get rid of him, and let's replace that with 201. And then we'll activate him. I'm sitting here like, it's not that difficult. Why is it not coming up? It's because I typed the wrong IP address. Trying to go too fast. That's what happens. Okay, so that should give us, okay, much better. So let's save him and save him. Okay, so show IP BGP summary. All right. So BGP has been established with ISP-A on router 1 for 12 seconds and counting. Obviously, we're not going to be learning anything. We're not advertising anything. We haven't done any of that yet. Let's just go ahead and do the same basic peering on between B and router 2. Hopefully I don't typo this again. So router BGP 2, we said for this one, right? We'll say neighbor 201.1.2.2 remote AS is 101, okay? And we'll go ahead and activate him. All right, and then we'll save that. Then if we come to router 2, router BGP 101, we'll say neighbor 201.2. Why can I not remember these IP addresses? Why am I struggling with remembering these IP addresses? 201.1. 201.121. 201.121. Remote AS is 2, and we'll activate him. Okay, I was gonna say I should have did 201 and 222 and 111. That's what I should have did, but okay. So show IP BGP summary. Okay, so looks good. We're up. Obviously, same story, no prefixes, but that's fine. We're going to be taking care of that here soon. So let's save. Let's basically just save everything. Okay, so all the routers should get a save. Switches too. Okay, so there's one more thing I want to do before we call this one quits, and then I think we'll be in a pretty good spot. So that's the connectivity between us and the service provider, all right? However, the advertisements that we're going to be making to the internet are this address space here, the 101.1.0. That's our IPs that we own as Cisco, right? We're going to advertise them to the service provider. So we'll probably have some larger conversations around the advertisements that we do, especially if we entertain another data center, which I'd like to do that in future videos. So if this is the only address space that we own, we might want to either chop it in half at some point later on, or if we can't figure out a way to chop it in half, and maybe the infrastructure team's fighting us, and it's a big deal. Maybe we just advertise it out of a primary data center and it's kind of there in a backup data center, like a disaster recovery scenario, and it'll only get advertised, like maybe it gets advertised but at a worse metric, I'll call it. So there's ways around, there's things we can do and engineering that we can take into play, but we'll have all those conversations later. But anyway, we're going to advertise the entire /24 to both ISPs, okay, for the moment. And then again, next video, maybe the third video after this, we'll start to adjust the advertisements. So how are we going to do that? We have to, essentially, our firewall is going to need to be part of this picture too, okay? So our firewall is going to be the default gateway for our data center, and it needs to have an IP address in that range, and that's also going to become, the NAT address that private addresses get translated to. So these are all these considerations we have to start to think about. So what we'll do is we will make the firewall.5, okay? We'll make router 1, 1, router 2, 2. We're going to have to do HSRP between them, okay? And you'll see why. We don't have to do that, actually. We don't have to, but I think I want to start with that design out of the gate and then kind of explain the mentality and why you might do that versus doing routing. So we need 4 IP addresses kind of out of this range to kind of make this work. And then once we configure all those IP addresses, we should be able to start to advertise the addresses out, because they'll be in our table and they'll actually show up in the ISPs. So let's just start there and we'll kind of branch out from there. So if we show IP interface brief, all right, we have 801 and we have 802. What we're going to have in a minute is a second sub interface off port channel 1 with a new VLAN. So I'm going to call it 901. Okay, I'm going to just use another high-end VLAN number that we don't think we're going to use, and that's going to be affiliated with this public address space that we own. Okay, so on router 1, let's go ahead and do interface port channel 1.901, encapsulation.1q 901, and we'll give it the IP address 101.1.0.1, just like we had said. All right. This time it's going to be a /24 mask because that's what we own, okay? Now we will do HSRP, and since we're on a router, it's now standby as opposed to HSRP. So we'll give it standby. We can't go 901 because it's too high of the range, so we'll just do standby 1, okay? So in this particular case, we can't match the VLAN with the standby, and that's okay. It's, like I said, it's not the end of the world. It just makes it harder to kind of track things and marry things up. So standby 1, whoops, we have to say IP. So the default gateway, let me think about that. Maybe we want to make the default gateway .1. Why don't we make router 1's real address be 2, router 2's be 3, the gateway would be 1, the firewall will be 5. Let's do that. Let's just do that. So let me exit out of this mode. Do actually interface port channel 1.901. We'll say IP address is 101.1.0.2 in this case. Then we'll say standby 1. IP is 101.101. That's going to be shared between the routers. We don't need the mask. Right, that's all we got to do. Standby 1. Standby 1. Preempt. Standby 1. Priority. We'll stick with our guns and do 105. And then we'll get into tracks and all that jazz later. Let's just get HSRP up. So, and show run interface port channel 1.901, okay? All right, fair, right? So we got the IP address, we got the standby. Let's get router 2 going. IP in this case is going to be 101.103/24. Standby 1 IP 101.1.0.1. Standby 1 preempt. Okay? If we show standby, I don't suspect we're going to see anything yet because we haven't configured that VLAN on the edge switches, and so it has no idea how to get over to the other side. Okay? So they're probably going to both be in like the same state, if you will, which is obviously not correct. So he actually went active. See, he's active. So right now they both think they're active, which is because they can't communicate with one another. All right, we'll fix that. That'll fix itself once we do the VLANs and stuff. So the edge switches don't have 901. They only have 801 and 802. All right. So we're going to give it VLAN 901, and we'll call it Internet. Name INET. Okay. Because remember, the whole reason behind this design is that later on, if we dump in some WAN routers and we want to maybe do like DMVPN from branch sites and stuff like that, they're going to need internet access. And the only thing we have to do is plug them into the edge switch and put them on VLAN 901. That's it, right? It's super simple design. It's not simple, it's flexible, right? It's highly flexible. So he's got VLAN 901. Since we're not pruning anything and all the trunks are in place, that VLAN should naturally make its way to where it needs to, which in this case is the firewall and the other router, okay? So let's configure 901 on this guy. Name INET. All right, so that should be all we got to do there. So again, if we show interface trunk, right, not to harp on it, but we can see port channel 1, right? So port channel 1 is the one going between the switches. So we can see it's now allowing 901, okay? Let's hop over this one, show interface trunk. So see it made its way into port channel 1, okay? So that's a good sign. So let's go back to Edge 01, or actually, let's check the routers real quick. So active, and see he switched to standby now. So show standby. Okay, so that's better, right? So now we can see state is standby, virtual IP is the .1, okay? It can see the 2 MAC addresses, and we can see that the active router is .2, his priority is 105. So communication is there now. That's good, that's what we want, okay? So again, we're just building the blocks, and we'll tune all this stuff later. So let's go to the firewall, and let's see if we can't get him his .5 address real quick. All right, so I don't have the firewall up yet. Let me bring him up. Show IP interface brief. Okay, so remember we had port channel 254 that was going down to, oh wait, I think we have to do a port, do we have to do the port channel up to the edges? Let's see here. Show run interface gig 1. Okay, so that's port channel 2. Okay, I thought we did that. Show port channel, this is a router. Show ether channel summary, right? Yeah. Okay, good. All right, good. So 1 and 2, yep, go up to the switches. That's port channel 2. Port channel 2 has nothing assigned to it yet. Okay, good. So what we want to do is conft interface port channel 2.901, right? Encapsulation.1q 901. We're going to give it IP address 101.1.0.5, right? /24. And with any luck, show run include route. So I believe, right? So we had staged this route before because we knew we were going to do. Okay, good. So we have IP route quad 0 101.101 name outside. That's a good thing. Now let's just see if we have connectivity to that address. Okay, not looking good. So I may have forgotten a step here. I may be jumping the gun here. So, and that's okay. Because I do think that I may have forgotten something. Let's just take a couple baby steps here. So we think, right, based on what we saw from HSRP, the two routers are able to communicate with one another. So I should be able to ping 101.103. Okay, I can, and then obviously 1 is kind of local, if you will, because it's the shared VIP. Can I ping 5 from here? I'm going to guess no. Oh, I can. Okay. So I can ping 5 from router 1. Let me check router 2, 1.0.5. Okay, I can ping, maybe we just didn't give enough time, to be fair. So I can ping 5 from router 2. Let's go back to the firewall, and let's hit the up arrow. Okay, so there's something on the firewall side that isn't happy. Show IP ARP. So we're learning. Did I put the wrong route in there and I'm just blind? So we got 1, 2, 3, and 5. We have all the MACs, but why don't we have connectivity? What if I ping? Let me see something here. Let me ping 2. Okay, that works. 3 works. It's just I just can't ping 1. I think it's something to do with the HSRP, or I fat fingered a route. Is that right? 101.101, right? 101.101. No, that's the edge switch. 101. 101.1.0 Showrun interface port channel 1901. 101.101. Let me take this out for a second. I just want to see if I do ping this. Yeah, I cannot ping the HSRP virtual IP address. Why? Why can't I? Let me check. But the routers can ping the firewall, but the firewall can't ping HSRP. Edge switch. Let me just look at the edge switches. That tells me it's not a trunking problem. It's like, I hope this isn't some weird HSRP bug, because that should work, to be perfectly fair, and it's learning the MAC. Show run interface ETH13. Show interface trunk. So port channel, let me just get my bearings here. Port channel 3 is going down to the firewall, right? So port channel 3 is going down to the firewall. Show interface trunk. We can see that it's allowing all the VLANs. There's nothing error disabled. Everything looks good. I see no reason that that ping should not work. Not to mention, so let me just double check one thing here. On the cores, admin Cisco, show run interface VLAN 254. So we're doing the same thing. Commands. We're doing the same thing here, right? We just had the track in play, but if the firewall can ping this, that would make me feel better that it's not Although these are, the HSRP's going between Nexus, not Catalyst 8Ks. This screams bug to me. Let me go back to the firewall and try to ping that one. I'm almost positive we can, yeah. I'll tell you what, I'm gonna stop. We're in a good spot, right? We're in a really good spot. We've done a lot. The video is it's at almost 40. It's just shy of 40 minutes. So let's stop here. I will power cycle these routers. If I find that there's some config that I am 99.9% sure that config is fine. If there's a config issue, I will obviously admit to that and bring us up to speed next video. But I'm going to try power cycling these boxes and see if that just shakes them loose. Because remember, these had the weird gig 4, 5, 6 or whatever originally. So I'm almost wondering if these things are just kind of flaking out. But I'll stop it here. We'll pick back up in the next one, and we'll start to talk protocols and all that jazz. So I'll see you guys there.